In step 6, we'll perform a sound analysis for our proposed stage using 3D proximity analysis. First, we'll use the Buffer 3D geoprocessing tool to buffer our stage point feature by 1,500 feet. Then we'll symbolize the new stage underscore sound underscore 3D multi-patch feature class as red edges and set the transparency to 50% so we can see through to the buildings that are impacted by the sound and those that are not. We'll explore the scene and note that the nearby hotel with twin towers is inside the sound buffer and will be impacted by sound from the stage. In ArcGIS Pro, I'm going to activate the analysis ribbon and click on the Tools button to open up the geoprocessing pane. And in the geoprocessing pane, I'm going to search for Buffer 3D. And then right click on the Buffer 3D item and select Locate. And I can see it's located under 3D Analyst Toolbox under 3D Proximity Tool Set. Go ahead and click on Buffer 3D to open up the tool. We'll set the input features to stage, the output feature class. We'll save it in our project geodatabase as stage underscore sound underscore 3D. The distance we want set to linear unit, and the units that we want are international feet, and the distance is going to be 1,500 international feet. Go ahead and leave the buffer quality set to 20 and click Run. And that created our 3D dome that models the sound projecting from the stage. Go ahead and close the geoprocessing pane, and if I zoom out, I can see there's our 1,500 foot 3D buffer. Now I can't really see what's impacted, so I need to re-symbolize that layer. I'm going to go ahead and click on the symbol patch for Stage Sound 3D. And in the symbology pane under Gallery, select red with edges. And then under Feature Layer ribbon, set the transparency to 50% and click Enter. Go ahead and close the symbology pane. Now I can see which buildings are impacted by sound, and it's 2 hotels that are pretty close to our proposed stage location. Go ahead and reset my scene and save my ArcGIS Pro project. In step 7, we'll see if we can mitigate the impact of the sound on the 2 hotel towers by analyzing directed sound using interactive 3D overlay analysis. First, under Modify Features, we'll use the Slice Multi-Patch tool to slice a horizontal plane and delete the top. So we're projecting the sound out towards the ground. And then we'll use the Modify Features Slice Multi-Patch tool again to slice a vertical plane and delete the back. So we're projecting the sound out towards the front of the stage. Last, we'll explore the scene and note that the hotel is now outside of the directed sound buffer. Back in ArcGIS Pro, I want to activate an edit session and turn on the Modify Features pane. I want to make sure that my Stage Sound 3D layer is the only selectable and editable layer. And I'm not going to enable snapping. And then in the Modify Features pane, I'm going to go ahead and scroll down to the Divide section and locate Slice Multi-Patch. Go ahead and click it. That opens up the Slice Multi-Patch tool. The default setting is on the horizontal plane, which is what we want. So I'm going to select my 3D sound dome. And then now I need to click it where I'm going to slice it horizontally, about 1/3 of the way up. That looks pretty good. So over in the Slice Multi-Patch tool, I'm going to click the Slice button. And that sliced it horizontally in half. Clear my selection, and then switch my selection back to rectangle and select the top of the dome and click Delete. So now we're modeling our sound projecting out from the stage but not up. Now I want to slice my multi-patch feature on the vertical plane and go ahead and select my multi-patch feature again. I'm going to click in the middle and then slide the mouse down and click one more time to create my vertical plane that I'm going to use to slice my multi-patch feature. That looks pretty good. Over in the Slice Multi-Patch tool, I need to click Slice. and then clear my selection and use the select tool to select the back and click delete. All right, so now I'm no longer impacting the twin hotel towers behind the stage because I'm projecting my sound to the front. Go ahead and reset your interface and save your edits to your multi-patch feature. And of course, save your ArcGIS Pro project as well. During the rock concert, they'll be filming a video from the stage. So we want to analyze the viewshed using the interactive exploratory 3D analysis workflow. First, you'll click the exploratory 3D analysis button and then select viewshed and place an observer on the stage location. Then you'll select the viewshed and interactively position and refine the properties. Last, you'll use more options to convert the features to an observer point feature class. Back in ArcGIS Pro in the Contents pane, I'm going to go ahead and turn off the Stage Sound and Stage 3D layers. I want to zoom into our stage area and then activate the Analysis ribbon. And under the Workflows group, click on the Exploratory 3D Analysis dropdown and select Viewshed. This opens up the Viewshed tool. I'm going to leave all the default settings, including interactive placement, and place our observer right where the stage is located. And then if I hover over the observer again, you'll see it turns to a selection icon. And I'm going to select the observer. And then now I can use the various handles, and you can experiment with them to rotate and reposition my viewshed. So I want it positioned looking south at my crowd. I'm going to extend it around to almost 180 degrees and then extend the viewshed out to contain the entire venue area. All right, that looks good. The areas I can see are in green and the ones I can't see are in magenta. Now the problem with the tool is I can't save my results, so I need to export my observer point, and I can do that in the Viewshed tool under More Options and click on Convert to Features. And in the Export Viewshed Points under Output Feature Class, I'm going to name my Output Feature Class as Observer and click OK. And that creates a new Observer Point Feature class and Observer Point Feature. And if I close the Exploratory Analysis tool and then select and delete my interactive viewshed, I can see there's my observer point right there at my stage. Go ahead and reset your scene and save your ArcGIS Pro project. In step 9, we'll use the observer point we just created and recreate our viewshed using the ArcGIS Online Viewshed tool. So first, under Ready to Use Tools, we'll select Viewshed and set the input to observer and our distance to 500 meters or 1,500 feet, our resolution to finest, and uncheck generalized viewshed polygons. And then we'll rename our resulting map layer and feature class and set the transparency to 50%. Back in ArcGIS Pro, I'm going to activate the Analysis ribbon, and then in the Geoprocessing group, I'm going to click on the ArcGIS Online Ready to Use Tools dropdown and select Viewshed. That opens up the Viewshed Geoprocessing pane. I'll set my input point feature to observer, my maximum distance to 500 meters or 1,500 feet, my DEM resolution to finest, and then I want to uncheck generalized viewshed polygons and then click Run. And this sends my observer and parameters to ArcGIS Online, which runs the geoprocessing and then sends the results back to ArcGIS Pro Desktop. Go ahead and close the Viewshed Geoprocessing pane. And in our project geodatabase, we want to rename the feature underscore set as stage underscore viewshed underscore 3D. And that loaded as a feature layer in our contents pane as well. And so we're going to rename that polygonal feature layer as stage underscore viewshed underscore 3D. And activate the feature layer ribbon and set the transparency for our new viewshed layer as 50%. All right, that looks good. We can see the viewshed from the stage. Go ahead and reset your interface and save your ArcGIS Pro project. In our final step, we need to ensure that the building behind the stage won't cast a shadow across the stage. So we'll analyze shade using the custom sun shadow volume geoprocessing tool. First, we'll select the building model features behind the stage, and then we'll run the sun shadow volume geoprocessing tool for the date and time of the concert, July 4th at 6 p.m. Pacific Standard Time. Then we'll set the resulting stage shadow 3D to 50%, finalize the scene, and confirm that the proposed stage won't be in shadow at the beginning of the concert. Back in ArcGIS Pro, I'm going to use the Explore button to reset my scene so I can see both my proposed stage and the building just behind my proposed stage. And now I want to see if the shadow will impact the stage at the start of the concert. So I need to select my building, and it doesn't look like my building models are selectable. Let me make sure they're selectable. Now select the building. Now I'm ready to perform my analysis. I'm going to activate the analysis ribbon and click on the Tools button. That opens up the geoprocessing pane, and I'll search for Sun Shadow Volume. There it is right there. I'm going to right click and select Locate, and go ahead and collapse some of the tool sets that we previously used. And there we can see in the 3D Analyst Tools box in the Visibility Tool set is the Sun Shadow Volume geoprocessing tool. Go ahead and click it to open it. We'll set the input features to building models, and of course it's only going to use our one selected record. I'm going to click on the clock icon to select a start date of July 4th, 2025, and then reset the time to the start of the concert, which is going to be 6 p.m. Rename my output feature class as stage underscore shadow underscore 3D. I want to set my time zone to Pacific Standard Time. There it is right there. Oh, it looks like that reset my start time, so I'm going to go ahead and update that again as 6 p.m. Accept the remaining default values for my geoprocess and go ahead and click Run. And that creates my stage underscore shadow underscore 3D feature class in my project geodatabase and a feature layer in my contents pane. Now I need to go ahead and clear the selected feature, and I can't really differentiate the shadow from the building, so I'm going to set the transparency for the shadow layer as 50%. And there I can see that the shadow cast from the building at the start of the proposed concert won't impact the stage. All right, go ahead and turn back on my stage sound analysis and my proposed stage location. I'm going to zoom out and reposition my scene to capture my entire 3D analysis. Go ahead and reset my interface, save ArcGIS Pro. This concludes the demonstration.